Hello, in this video we'll talk about this approximation algorithms. So what is an approximation algorithm? So many real world problems we see which are very significant problems or NP complete. So for example, traveling salesman problem, 0-1 knapsack problem. So what is this NP complete? So it is a set of decision problems whose solutions can be verified in polynomial time, but the optimal solution we cannot find it in polynomial time. And NP complete is so this is the hardest problem in NP. So even if this problem is NP complete, even if a real time problem is NP complete, there are some ways to get around this NP completeness, and we can find solutions for that. So though we are not able to find out the optimal solution, we can find near optimal solutions in polynomial time. So near optimality is a good approach for finding the solutions. So an algorithm that returns the near optimal solutions is called an approximation algorithm. So in an optimization problem, so what is an optimization problem? The problem of finding the best solution from all feasible solutions. So several possible solutions are available. Among them, we have to find the best solution. So that is called optimization problem. So in any optimization problem, the potential solution has a positive cost. So now we wish to find a near optimal solution. So depending on the problem, we may define an optimal solution as one with the maximum possible cost or one with minimum possible cost. So for example, if we want to maximize the profit or minimize the cost, then the optimal solution should have some positive cost on that. So the problem can be so described as either a maximization problem or minimization problem. So now this approximation algorithm can be defined something like this. Given an optimization problem P, an algorithm A is said to be an approximation algorithm for P if for any given instance I, it returns an approximate solution, that is a feasible solution. So for any optimization problem, if an algorithm gives an approximate solution for even for a single instance, then that can be taken as a feasible solution for the entire problem. Now here we have something called as a performance ratio or approximation ratio. So let us assume that C be the cost of a solution found for a problem of size n, that is, it is an approximate solution. And we said that we do not know the optimal solution, okay, but here we just assume that we know the optimal solution, we know the cost of the optimal solution. So C star be the cost of the optimal solution for that problem. So an algorithm for a problem has an approximation ratio of rho of n. So for the given input n. So the maximum of this C by C star and C star by C should be less than or equal to this factor rho of n. So what it says is the solution that we have produced, or the approximate solution that we have produced, the cost, it should be within this factor rho of n. So that will be the optimal solution. So if an algorithm is able to achieve an approximation ratio of rho of n, then we can call it as an rho of n approximation algorithm. So this will be applicable to both maximization and minimization problems. And this approximation ratio of an approximation algorithm is never less than 1. It should not be less than 1. So for example, so we have taken that C is the cost for the approximate solution, and C star is the cost for optimal solution. So the approximate solution that we have found is near optimal. So for example, if the if in a knapsack problem, if the optimal solution is 200 and the near optimal solution may be some 180, then the the ratio it comes within that. Okay, for the maximization problems, what is given? C star divided by C should be greater than or equal to 1. So C star is the optimal solution. So for example, the weight is 200, the maximum profit we gain is 200, and C is 180, that is the optimal solution, near optimal solution or the approximate solution. So then that means it is greater than or equal to 1. 200 divided by 180 is greater than or equal to 1. So for maximization problems, the factor should be C star divided by C should be, here it is greater than or equal to rho of n, and C by C star, that is for minimization problems, it should be less than or equal to rho of n. So as we take this rho of n as a value as 1, then this one approximation algorithm will produce a optimal solution. And if the approximation algorithm has a larger approximation ratio, then the solution that we found will be much worse than the optimal solution. It will not be a near optimal solution. So one approximation algorithm will produce an optimal solution. And there are different approximation schemes available. An approximation scheme is in an approximation algorithm that takes epsilon value greater than 0 as an input. That scheme is called as 1 plus epsilon approximation algorithm. So for any fixed value of epsilon greater than 0, we can call that scheme as an 1 plus epsilon approximation algorithm. And another scheme is called as polynomial time approximation scheme. So for any fixed value epsilon greater than 0, if the scheme runs in the polynomial time for the size n of its input, then we can call it as a polynomial time approximation scheme. So in this kind of approximation scheme, any constant factor decrease in epsilon comes with a corresponding constant factor increasing in the running time. So as the epsilon value decreases, the corresponding running time will increase very rapidly. So these are some of the approximation schemes, and we have seen what an approximation algorithm is and how it is better for the NP complete problems. Thank you.